mind. Yes.
We have an isotope, Te, which is technetium.
Yeah.
Well,
Yeah, technetium.
are we doing around the world?
No, we're just gonna keep score. So it's 125 over 52. Okay, so for this isotope, how many neutrons does it have? Shh.
She doesn't know it.
Yep, Zach. Do you subtract them?
Yeah, you do.
Or is it just one
Not
of the numbers?
answering that question. You're supposed to know the answer.
Come on, Sora.
Alright. No, I got this. No. You should know this.
Yeah, you should.
5, 4, 3, 2, 1.
52.
What?
125. Okay, wait, let me do this.
That is incorrect.
Wait, I got you.
Wait, what's it? What?
177.
What answer?
Wait,
What?
did you take?
177.
That is incorrect.
Wait.
Sarah, you can just keep guessing.
No, 73.
No, I know it.
There's a difference.
Page.
Yes, 73. Although I'm not going to give you a point for that.
No,
because
come on, I got
you
It's
actually
125.
after I told you no to all your other guesses.
Yeah, but I asked if you subtract, and I didn't.
Yeah,
So,
why you
I know, but I
arguing?
thought it was wrong.
Okay, so
Honestly,
when
I
you're
thought you
looking
liked
at an isotope, this number down here represents the number of protons. This number up here represents the atomic mass, which we should all know that the atomic mass of an element is the protons plus
The neutron.
the neutrons. So if you subtract the number of protons from the atomic mass, you get the number of neutrons.
Okay.
I also thought it was 50. So that's what you just said.
All right, well, we all learned something today then.
But technically, I still got it right. It just took
No, you
me a second.
It took you like
Did you say
7
75?
tries.
It was 3.
73 was the correct answer. Okay, Tim, the maximum number of electrons that can be found in any atom's second principal energy level.
Skip.
That can't be.
I know.
The maximum number of electrons that can be found in any atom's second principal energy level.
I don't know.
All right, Zach.
6.
Oh, come on.
I know it. Come on, I just missed one.
Sarah.
8.
8 is the correct
Oh.
answer.
I was right.
Sora.
All right. So we're on to Hope. Okay, and we just kind of answered this question, so hopefully. Okay, 2 different isotopes of the same element will have the same number of blank, but a different number of blank.
Same, like, atomic number was different, like.
Same number of what?
Protons.
Protons, all right, but a different number of
Yes.
One.
yes, a different number of neutrons. Very good.
What else were you gonna guess?
I
Electrons.
was going to.
It'd be wrong, but that's another option.
That would be an option, but
Potato salad's not an option.
we know that in any free element, the number of protons will always be equal to the number of electrons.
You just gotta think that an isotope is usually protons and neutrons, it's not electrons.
So you see like a card.
Yes, the electrons don't change.
Thank you.
Unless it's bonded with another atom, the electrons do not
Thank you.
change.
Thank you for that.
Okay. Now, I'm not going to put any of the theories from chapter 4 on your exam.
Thank you.
You're welcome.
Thank you. You're not a teacher.
Alright, so
I mean,
we're up to Zach.
Try to put his.
Everything else
True or false? The general region of space where an electron is most probably found is known as.
Did you just say true or false?
Oh, right, yes, sorry. My bad. The general region of space where an electron is most probably found is known as an orbital. Is that true or false?
True.
True, very good.
I was gonna guess
So,
two.
correct.
Okay, Melly, true or false? An electron can behave as either a wave or a particle.
True.
True, very good.
I didn't even know if true or false.
Yeah.
Oh. Alright, Walton, true or false? Each atom can be identified by the number of protons in its nucleus.
False.
Oh, it's true.
That is true.
It's okay, one.
You got
nice time.
Shane?
Yeah.
It's okay, well.
Right. So
But-
generally, unless you're operating in the far reaches of space, the number of protons in an element will never change.
Oh.
Unless you're looking at nuclear fission, then that's a whole different ballgame. Okay. So we're up to Sarah again. True or false? An atom that gains 3 electrons will have a +3 charge.
False.
False.
Or
Very
a
good.
-3, right?
Yes, it would be -3. Alright, and I'm gonna move this actually up here just so I can make sure that they are hearing the questions and answers. Alright. Okay, so we're up to Tim. Alright,
You okay?
who developed the first experimental atomic model?
Oh.
His name is on your study guide.
Yes, I guessed it.
Yeah.
Oh, I got it.
Okay.
I knew it.
Say Louis Mattis.
Hold on.
Can I look at my study guide?
What?
Can I look at my study guide?
I mean, you can, but there's plenty of names on there.
There's
So.
3.
Yeah.
So a couple of different names on there.
But
We're
it's
in
all-
chapter 4.
Yeah.
Neil Bohr?
That is incorrect.
Pick one. One doesn't have one yet.
Walton,
What?
What?
He just
What?
said
Dalton!
Sarah,
Who's the guy?
Dalton.
John Dalton.
Oh.
Very good.
I thought we were talking about.
Trade.
Oh,
It's
Yeah.
fine. You'll get it
Alright.
next time.
all right. So that was Tim. All right, Hope. Who discovered protons?
I still get it.
His name's also on your sheet.
Ernest Rutherford.
Ernest Rutherford.
I
Very
was gonna guess
good.
that before I looked down, but I didn't.
All right, and Zach, who developed the planetary model of the atom?
Who got this?
On my study guide.
Yes.
Yes,
Yeah,
it is.
The last one.
Niels Bohr.
Niels Bohr. Very good.
Planetary
The
model.
planetary model of the atom. That is also the model that we use today. And so you guys understand what it means by planetary.
Of plants.
Plants. Yeah, sure.
Planet.
Planets, which revolve around the sun, similar to the way that electrons revolve around the
each other.
nucleus.
There you go.
Woo, okay. Alright. So we're up to, that was Zach. We're up to Melly. Okay, which has the least mass? An electron, a proton, or a neutron?
No,
Sarah? No,
Oh.
I'm gonna go to Walton.
No.
So there was neutron, electron, and what was it?
Neutron, electron, or proton?
It's electron.
Electron. Very good.
Yes. Terrible.
Which is why they
I
were.
was gonna say electron.
No.
We can catch up on.
And
Okay.
Off the wall.
So, all right. So, whose question was that?
that was mouse.
It was
Melly's.
yeah,
Okay. So, Walton. MRI machines make images through changing blank in an atom.
Changing blank.
So if you know what the letters MRI stand for, you should be able to figure out the answer.
Where's the sample?
Well,
No, I'm not going to tell you that.
Well,
MRI.
I'll look it up.
Quickly. Yes, it's on page 98.
Quickly.
MRI. By changing the magnetic fields.
The magnetic field. Very good.
Mechanical.
All right. Anybody know what MRI stands for?
Magnetic reading
Reading imagery.
Magnetic resonance
Yeah.
imaging.
Yeah.
Yes. All right. Which is why if you go to get an MRI, you have to take out any jewelry that you're wearing. And if you have any kind of metal rods or metal plates in your body, you can't get an MRI.
Right.
So if you have like
I don't
a
have
place
no
like knee or like hip, you can't get an
From the
MRI.
car accident.
No, they'd have to do a CAT scan.
What would happen if
Even if
they
that's
did MRI?
The machine would rip the metal out of your body.
Oh,
you
dear
get-
God.
Yeah, that.
I want to know
Would
who
not
got
be fun.
experimented on that happened though.
Well, I think
Yeah,
they
but
were
they
smart
just-
enough to figure out that they
Yeah.
were working with magnets.
Yeah.
Very large, heavy magnets. Yes.
Can't on X-rays you can see your like earrings too? If you don't take them out?
Yeah. X-rays and CAT scans are okay to have jewelry in, but MRIs cannot. All right. Although usually they ask you to take them out anyway, just so they don't
So I had an
distort
X-ray
the image or anything.
Just-
All right. So that was Walton. I did give you the point for that, right?
Yeah.
You
did.
Okay. All right. So we're up to Sarah. All right. Mass number equals the number of blank plus the number of blank.
Oh, mass number.
Also
Number
called
of
atomic mass.
Atomic mass. Oh.
I know this one.
So wait, it's atomic mass. How you find that? Blank plus blank.
Yes.
Sarah, we
It's just the atomic mass is added up.
by what?
What do you
Oh,
mean?
I know it.
So, miss a page.
She doesn't know
Miss
it.
a page. Miss a page.
Wait, what?
Think back to our conversation
No, can
about
you-
isotopes.
No.
Yeah, wait.
Her.
Wait, stop.
No, she doesn't
Oh,
know
it's
it.
atomic number plus
She doesn't know.
no atomic mass.
You're wrong, Sarah.
Wait, just give it a second. Wait, can you repeat the question? Can you just repeat the question?
You get more time
Please.
than anyone else.
Mass number equals the number of blank plus the number of blank.
She doesn't
Atomic.
Atomic
Atomic mass.
wrong.
All right, Hope.
Protons plus neutrons.
Protons plus neutrons.
Well, someone
Very
could have said
good.
that. Either protons, electrons, or neutrons. Thanks to that.
Oh,
No, you're winning. So now we're tied.
Sarah,
Well,
relax.
All right, so Tim.
I knew that one. Sarah didn't.
Oh.
You know?
Tim.
Sorry.
The electrons in the outermost energy level are the electrons in the outermost energy level that are important in bonding are called.
See, you got this.
I know this.
She doesn't know.
My hand was up first, so.
Oh, that's fine.
Zach currently is losing. So
He's not losing, but he's.
Oh, come on, Tim. Really?
I can tell this one.
oh, I know what it is.
What?
I can see that. I don't want to get
I
a
don't know.
Zach illusion.
I mean, it's 1.9.
I didn't say.
Can you read
I said he's not losing.
The electrons in the outermost energy level that are important in bonding. So it basically determines which atoms are going to bond with which other atoms.
You don't even know. You're like, wait.
Sarah, I want to get the question right.
Yeah, but you don't know it. Zach doesn't even know it. Come on.
I guess.
All right, Walton.
No, he doesn't know.
Neutrons.
No. I got you.
Neutrons are in the
I got you.
nucleus.
Oh,
This is
yeah.
easy.
Zach.
Does he?
Did you know it?
Yes.
I don't know.
I literally just told you to look at your study
I
sheet.
already got it wrong.
Here we go.
Zach, what is it?
Balance
It's
electron.
not my
Valence
anymore.
electron.
You know what?
You know what?
That's what you like.
Alright.
Now we're.
Gotta go up
You're.
on
Yeah, your head.
Everybody heard the answer to that.
Yeah.
Valence electrons. Very good. Okay, so I'm not gonna do this as a competing question here, but oh, and you know what? Actually, we could. Whose question is it? Hope's. All right. No, you know what? It's gonna take too much time. You need to know how to write the electron dot notation for an element.
I would do that.
Oh yeah, don't you do like the
No, don't.
Oh, the dots on the side, like how many as electrons, not electrons, how many you put,
yeah, like 1, 2,
Right.
the chemicals
Yeah.
surrounding
and you start on the right side. So yeah.
Yes, the valence electrons around the letter of this
So like,
element.
say you did like calcium and it was like number 2 and number 6, you just put like 6 electrons around it.
What do you mean by number 2 and number 6?
Like on the periodic table, there's like a 2, 6 under the
Those card crafts are getting
thing.
What?
What are you asking?
Yeah, what do
Go
you-
to the next question.
The valence electrons. You use the valence
And
electrons.
there's like the 2, 8, 18, and 1. Those are the electrons, aren't they?
So that's the
Like
last
the
one.
shells?
No.
Look at the they are, aren't they? That's what they are, right? The shells?
Yes.
7 on the outside, there was 7.
Yeah, whatever the last,
What-
the outermost shell. So yes, yes, you're right.
I know.
Very
Y'all thought
good.
I was crazy.
All right. Okay. So Hope, your question is: a negatively charged ion is called.
You don't know it.
Negatively charged
I think I
ion.
know what's
You don't know it.
Exxon.
Yes.
That's part of DNA.
I know.
All right. Who is Walden still behind?
It's
What about
Navy,
Tim?
isn't it?
Yeah,
It's
Tim.
anion. Very good.
You
Oh,
Tim.
I didn't even see Tim's hand.
Oh.
I'm sorry.
That's on the.
All right. The correct answer is an anion.
Anion.
Cations are positive because cats are positive, according to Emily Kratz.
No, they're not.
Not according to me, though.
Yes.
How's our
Okay.
Gucci is
Cats climb on my counters and eat my flowers and knock over my vases and generally
We would never.
destructive creatures. Oh, I have thrown my cats across the room before. They really don't learn, though.
Well,
In fact,
if you
they
teach me young.
maybe. I don't know. My cats are spiteful. And they will, like, my one cat will literally jump up on my counter, look me right in the eye, and go, whoop, knock stuff off my counter.
Like,
I'm like,
we've
you.
So OCD.
we've had older cats, and like my sister just got a kitten, but like, if you teach him young, I don't know. It seems like he's a lot well behaved, better behaved than older ones.
Next question.
Yeah, I don't know.
Yeah.
Well, plus when they're kittens, they can't jump on the counters yet. Then they get older. It's a different story.
Now we should
I don't know. All right, so that was Hope's. All right, so Zach, who arranged a number of the elements in triads on the basis of similar properties?
I know.
This is a person.
Yeah.
Yes.
No.
Who's talking to you?
You guys are so kind to each other. Who arranged a number of the elements in triads on the basis of similar properties? They're named after him.
Good, when we were taught, I get to take this one.
I don't know.
Plus I'm
Whose hand was
behind,
up
'cause
first?
Oh, I don't even know.
You don't even.
I lost
Go.
my last point.
I have the answer.
Yes.
Text me. You're fine.
Doberine is
Yes.
triad.
Yes. Doberiner is the
Yes,
correct
somebody said.
answer.
Right here.
Ooh, ooh,
Right here.
ooh.
All right, now we're up to Melly.
Thank you.
What chemist arranged the elements according to increasing atomic masses and thereby discovered the relationship he called the law of octaves?
What?
We all know.
I don't know. This.
Come on, Zach's winning.
You're all tied. Although Walton's gonna be ahead once if he gets his
He's
question.
gonna be
Well,
ahead.
you see, I'll
I went
Well,
first.
well,
No.
Yes.
Yeah, it's
John Newland is the correct answer. Yes,
Yes,
very
sir.
good.
All right.
Okay. All right, Walton. Whose work resulted in the revision of the periodic law and the atomic number being used as the organizing factor for the elements of the periodic table? So this would be the periodic table that we use today.
There's two. I forget.
Well, one was by atomic mass, and the other one was by atomic number. So the atomic number is the one we use today.
And it's a person, right?
Yes.
Mostly.
Mosley is.
Yes, sir. Don't give it to Sarah.
Oh my
All
god.
right, Sarah. This Nobel Prize winning chemist devised the electronegativity scale.
Falling.
Pauling, very good.
There's two.
No, I'm not.
Well, I might have put, did I put Pauling's electronegativity scale?
No, you just put Holmes and Mosley.
Oh, okay. All right, Tim. In general, where are the non-metals located on the periodic table?
No, there's one.
Actually, great cat.
My hand up was first.
You mean like the direction?
Yes.
Okay.
So if you're looking down at the table, what side are the non-metals located on?
On the right?
On the
Yes.
right.
Yeah.
Very good.
Nice. Tim got one right.
Sorry, oh my god, I can't.
No, I'm not.
All right. Hope. In general, which is the group of elements that tends to have the strongest electron affinity?
Repeat it.
In general, which is the group of elements that tends to have the strongest electron affinity?
You mean like metals, non-metals?
Yes. Yes. So that means that they can hold onto their electrons,
You don't know.
which would probably mean that they have how many valence electrons if they're really good at holding on to them? Probably 8, yeah. So which group would that be?
Oh,
Well,
she.
Would be the noble gases. Sarah's behind technically.
Yeah.
All right, Sarah, what is it?
No way.
Metal.
It's
True. Halogens?
You don't get to keep
It's either
guessing.
metals or halogens.
You got it wrong.
She got it wrong.
What is it, Zach?
Halogen.
Halogens is the correct answer.
I said metals or halogens. Quick, they got
You
it
don't
right.
get 2 answers.
Yeah, but
All right.
Wait, no, halogen. No.
because it was either true.
Oh, no.
All right, so that was Hope's question, so we're up to Zach. Okay, the lightest and most abundant element in the universe, extremely flammable in the air, and is used in the industrial production of ammonia.
Okay, I actually know this
Hydrogen.
Hydrogen. Very good.
Yes, there is.
one.
Why is
Stop
it
calling each other trash, please. That's not kindness.
You should take away points for that.
No.
Yeah.
He said
Oh.
trash like
Alright,
5
stop.
times
Sir,
already.
why-
Okay. No, I think that's a good idea. The next person who insults one of their classmates will lose a point.
Sarah, you're
Sid,
first.
no, hard time with that.
So are you. Congratulations. I'm glad you're winning.
Thanks.
Okay. So we're up to Melly.
Oh, shucks.
Existing as diatomic molecules, this gas is tasteless, colorless, and odorless, and accounts for approximately 78% of the Earth's atmosphere.
I say my hand was like first.
It was. You're.
Most
I
of,
need this. You're gonna win.
Yeah,
You're
well, I guess it's not the most abundant, but
Exactly. So let me. You're gonna get a point.
It's how much of the Earth's atmosphere?
78% of the Earth's atmosphere.
I was fast.
sense.
One of the two. That one or the
Good job.
And they like to hang out in pairs.
fire.
She doesn't know it.
I don't know.
All right, so I'm
I'm
going to go to Tim. Do you know the answer?
Nitrogen?
Nitrogen is the correct answer.
Yes.
Very good.
So you don't get it.
Did you hear what Zach just said?
Zach
Zach just insulted me. He loses the point. He just insulted me. It was
No,
weird.
that wasn't an insult. That
You
wasn't
didn't
an
even hear what I
insult.
said.
What did he say?
What did you repeat it for?
You say it. What did I say?
What did you say?
Exactly.
No, he said, he's like, yeah, Sarah didn't get it right or something.
So lying
That's
about
an
someone
insult.
making fun of you is even worse.
I don't
Yeah.
know. He doesn't like that. No, he
Fine.
said
No.
Sarah didn't get it right or something.
Okay, that's true.
That's not
Okay,
insulting.
that's rude.
How's
Oh,
that rude?
shush.
I said
That's
something.
not insulting.
And that's not rude.
Please,
That is
shush.
Okay, so if you call name calling,
All right,
calling,
fine.
you lose a point.
Yes. I mean,
Okay, so we're up to
really-
Walton.
Yeah.
This element constitutes 21% of the Earth's atmosphere and is the most abundant element in the Earth's crust.
oxygen.
Oxygen.
Yeah.
Very good. And it is essential for
I
life
thought you didn't say
in
that.
animals and plants.
Well, there's only one other option.
Animals and
Sure.
humans, sorry.
It's good.
Okay, Sarah. Which non-metallic element is referred to as brimstone in the Bible and exists in a variety of forms, including a brittle yellow crystalline solid in its native form?
Sulfur.
Sulfur.
No,
It is
I just spelled
SULFUR.
it. No.
Yeah.
Yeah, I think
Yeah,
that's
that's
right.
it is right.
What?
Sulfur spelling.
Oh.
Yes.
I just did. SULFUR.
No.
Yes.
You almost said
not on
ER.
my watch.
What is it then?
All right, Tim. According to the Big Bang Theory, this is one of two questions about the Big Bang Theory that will appear on your final. According to the Big Bang Theory, the very first elements would probably have been
Oh.
We're up at the same time.
so generally Big Bang Theory we assume that things started out very simple and became more complex over time. So probably the first two elements would have been
No,
You're looking at your periodic table.
I know that. Okay. Hydrogen and helium.
Very good. All right. Hope. Elements with three-letter symbols are A, all radioactive, B, unverified, C, are all post-transition metals, or both A and B.
Repeat the little question things.
A, are all radioactive, B, have not been verified, or C, are all post-transition metals, or both A and B.
So, you know.
Yes, I know it.
With 3,
Yes, with three-letter symbols.
it'd be B, right?
Unverified?
Yeah.
That is incorrect.
It isn't?
Please.
Come on, he's already winning. He doesn't get it.
No, Sarah. Come
Walton.
Come on.
on.
What? He's already
So A was the all radioactive, right?
Mhm.
B was hold on. B was the post. No, the
Unverified.
post transition metals.
Oh.
No.
No.
Oh my. Come on, Zach's already winning.
All right, well, there's only
Come on, Zach's already winning.
So
there's really only one option left here.
Just in case
But
they're
there's-
not all radioactive.
yeah.
Actually, the correct answer would have been D, both A and
That's
B.
a-
They are all radioactive and they are all unverified.
Well, it could have been just
Yes.
that.
Oh.
Yes, Sam.
117 is radioactive.
Yeah, but they don't know.
We need
much about it.
117.
Just because they don't have the symbol like radioactive by it doesn't mean.
Yeah, it actually
Yeah, it
does.
That's why I
mean
said
that
it
it's
was
not radioactive.
Yeah, but she said before when I asked her about it that some of them they're not sure if they already said.
Well, it's unverified, so I guess they
Yes.
assume that it's radioactive. So, well, now you know. That question will be on your final, so try to remember that one. They're not post-transition metals. At least you know that one's not true. Okay. All right, so we're up to, that was Hope's question?
Yeah.
Okay. So Zach, graphite and diamond are both composed of the same element, carbon. Is that true or false?
Come on.
True.
True.
Oh, we
Very
should've
good.
got that one.
And hopefully after the
I
lab
learned
practical,
that
every one of you will get that
Yeah.
question correct.
I got that question.
lesson. I did.
Yes.
Wait, what'd you put? Coal.
I didn't write anything.
I put-
I wrote diamond.
Well, I know you-
I didn't write wood.
I didn't see
We
this
put
in
what
Now
the
we all
it
know
is.
that coal is not an element, correct?
I wrote
I
atomic.
know
Yeah.
it always puts compressed carbon makes coal.
So technically we weren't fully
So
wrong.
Yeah, I mean, it's not the hardest substance.
No, we put diamond.
Yeah,
but
no,
we put
coal
strong
is actually pretty brittle.
Oh,
So-
do we
Yeah,
have
but
to
don't
say
they
this?
Is
It was
it?
Who
Well,
said
it was
carbon?
what is the
Element.
hardest substance, and then what is it composed of?
It was. What's
Was
the
that,
hardest
like, two
crystal?
separate
What was
questions,
it-
though?
What element was it?
Yeah, so yeah, it was counted as separate questions. I don't remember. Did you get that one right?
I got the diamond. I think I probably put carbon because I know it came to carbon.
I know I
I
definitely
think
put
it was,
carbon.
but it was about half and half. A lot of you got it. Well, like half of you got it right, half of you got it wrong. Okay, but now you're all gonna know
I mean,
and
they both
remember.
start with a C.
But coal isn't an element.
But
Don't
isn't
understand.
compressed coal a
Bro.
diamond or no?
Well, it's
We can't fight this anymore.
coal under intense pressure. Yes, but coal is not an element. And the question was specifically,
I'm wrong.
what element is it formed from?
I know. I'm just trying to understand. Okay.
Okay.
Oh, you need to
Okay. So we're up to Melly.
Yeah.
True or false? The presence of calcium or magnesium ions in water make it hard.
True.
True. Very good.
calcium and what?
Magnesium.
Yes.
Ion?
Yes. Okay. Walton. Halogens are easily obtainable in their elemental forms. True or false?
Halogens are usually obtainable. In what form?
In their elemental forms.
False.
False. Very good.
False.
Just are gonna make fun of you for like the rest of the year.
There's only the one more week left, and I never even said bolts before.
Well, it's
I only said thanks. That happened.
Okay.
It's
All right.
just-
So the next set of questions, I'm going to give you a few examples, and you need to tell me what category it belongs to on the periodic table. All right. So the first one is for Sarah: helium, neon, argon, krypton, xenon, and radon.
These are. Can I look at my periodic table?
I'm going to say no for this
that's
one.
Wait, can you repeat them again? Wait, neon. So,
Helium, neon, argon, krypton, xenon, and radon.
halogen?
Oh my sir.
I don't
I think I
remember.
got this.
All right, Tim.
Noble gases.
Noble gases.
Oh, I
Very
should have
good.
known that from
Yeah.
helium.
Yes.
Yeah.
Yes, helium should have been a giveaway there.
I forgot about noble gases.
Tim's coming.
All right, Hope.
Alright.
Oh,
I
Oxygen.
think it's my turn.
What?
It's Tim.
Oh, right, Tim. Oxygen, nitrogen, carbon, and sulfur.
Non-metal.
Non-metals. Good. All right, sneaking up from behind. All right, Hope.
Thank you.
Good conductors of heat and electricity, usually hard,
Oh.
lustrous, malleable, and ductile.
No.
Metals. Good. Zach. Semiconductors.
Oh.
No.
Wait.
Okay, no.
Can I get another,
I have no idea though.
can I have another guess?
That's the only thing that would.
All right, Sarah.
Transition?
Oh,
No?
Zach.
Alkali.
No.
You just said that.
Wait,
Wait,
is it
wait. I know what it is then. I know what it is.
Kim.
Metalloids?
Metalloids.
Oh,
Oh, I feel like that was obvious.
I forgot there was metalloids.
Yeah, but that was like, I forgot.
was during the
All right. That was Zach.
Just like
All right,
halogens and
Melly.
gases don't connect, don't do
Yeah.
anything with
How much
electricity,
is
so how would that work?
What?
I was thinking how
I
okay.
forgot
can't see
the metalloids.
Oh, sorry.
Not you.
Fluorine, chlorine, bromine, iodine, and astatine.
I guess.
Mm,
Wait, whose turn? Oh, no.
are you giving up?
Yeah.
Oh. All right. Sarah. Halogens.
So,
I was gonna guess.
Yes.
All right, so that's it for that. All right, you need to know symbols and names for the elements. You guys should all be experts at that at this
We did,
point.
like 60 of them like last year.
No, there's how many?
No, I said didn't we do 60 of them?
Yes, we did 60 of them last year. And there's like 20, but I'm not going to put all of them on the test. I would focus on probably the ones that we used the most.
So, aluminum.
So, mercury, I would say you should definitely know. I know some of you missed that one last time around. Copper, you should know. Potassium, sodium.
Okay.
All right, and that's all I'm going to tell you about that. Okay.
Not hard. We've been learning like.
Yeah. Well, and we've been
like ever.
writing equations with all of them for, the last 4 months. Are we out of time?
Yeah.
All right. All right, you guys are dismissed.
here.